Students, in this class we will be studying to find the nth roots of unity. Okay. Now, for any complex number, we have proved that the complex number to be of the form r times e raised to the power of I of theta positive 2 pi k, where k is an element of Z. In particular, the values of k is going to be 0, 1, 2, up to n minus 1. Now, this complex number is written of the form r times, I've given you two representations. So this is going to be cos of theta positive 2 pi k positive I times sine of theta positive 2 pi k. This is one representation. Or we can also write it as r times cis of theta positive 2 pi k. Now I would be using this representation. So taking z to be in this fashion, let us see what happens when we have a complex number to be given as a unity. What they are saying is we are given z is equal to 1 and we are expected to find the nth root of this complex number. So this quantity has to be brought to represent this quantity, and to get this quantity, clearly the value of r should be equal to 1 and the value of theta should be equal to 0. Because if you were to take 1 to be the complex number, I know that any complex number can be represented in this fashion. So if I want to represent 1 in this manner, clearly r should be 1 multiplied with cos of, now theta, if I were to take the general form, where the general form is z is equal to r times e power I theta, then this representation is going to be z is equal to r times of cos theta positive I times sine theta. So this is the beginning, right? Now when theta is equal to 0, we would get z is equal to r times of cos 0 positive I times of sine 0. So this is what we would get. But we need to have 1 to be the left hand side component. So 1 can be equal to r of cos 0 positive I times of sine 0 if the radius r is equal to 1. So this is just an illustration or an example to what we have studied. So extending this over here, this is going to be 0 positive 2 pi k. I want to include all the coterminals, so that's the reason I'm placing 2 pi k positive I times sine of 0 positive 2 pi k. So this is what I've got for this complex number. So I can write this as z is equal to, now we need to obtain the nth root. So this is my 1 here. So let me write that down. So it's going to be cos of 2 pi k positive I times sine of 2 pi k, and that has to be raised to the power of 1 over n. Of course, the value of r is 1, that's understandable there. Now what we're going to do is we are going to be using De Moivre's theorem. So by De Moivre's theorem, we can rewrite this as z is equal to cos 2 pi k over n positive I times sine 2 pi k over n. So this is by De Moivre's theorem. Now I have already given you the Euler's representation that any complex number can be written in this fashion. So using the Euler's representation, I can write z to be as e raised to the power I times 2 pi k divided by n. Okay, so we have reached here. So from here, we should be in a position to obtain the final answer. Taking z to be as e raised to the power I times 2 pi k over n, let's find out the first root or the first value that we are getting when k is equal to 0. When k is equal to 0, we would be getting e raised to the power I times 2 pi of 0 divided by n, which is equal to e raised 0 times all this would be giving me 0, which would result in 1. Now when k, I'm going to write it down here, when k is equal to 1, I would get z is equal to e raised to the power I times 2 pi, k is 1, divided by n. Now when k is equal to 2, I would get z is equal to e raised to the power I times k is equal to 2, so that's going to be 4 pi over n. Now when k is equal to 3, I would get z is equal to e raised to the power I times 6 pi divided by n. So moving on, k is equal to 4, I would get z is equal to e raised to the power 8 pi, of course I is there, divided by n. When k is equal to 5, I would get z is equal to e raised to the power I times 10 pi divided by n. So all of these roots proceeding on, k is equal to n minus 1, I would get z to be equal to e raised to the power I times 2 pi n minus 1 divided by n. So we stop here because from k is equal to 1 to n minus 1, these are the values that will be producing unique roots. Okay, now having obtained this, we have to now obtain some properties. So in general, if you are going to be obtaining or writing down all the nth roots, so therefore the nth roots of unity, the final answer, you can simply write on the final answer as 1 comma e raised to the power of 2 pi divided by n I times e raised to the power I times of 4 pi divided by n, etc. e raised to the power I times 2 pi times n minus 1 divided by n. So these are the n roots or the nth root of unity. Now we can deduce a property, in other words we can obtain a property. Now if I were to take the roots as 1 omega squared, etc. up to omega n minus 1, then if I were to find the sum of the nth roots of unity, then that is going to be 1 positive omega squared, etc. up to omega n minus 1. This is a GP. Okay, this is a geometric progression with the common ratio being e raised to the power 2 pi divided by n. Okay, so that would be the value that we are getting, because the first value, you see this is the increment that we are obtaining. So we need to place the common ratio there. So if I were to write down the sum of the terms in the GP, then the formula is going to be s suffix n minus 1 is equal to a times r raised to the power n negative 1 divided by r negative 1, with the ratio being equal to e raised to the power I times 2 pi over n. So this is what I've got. Now let me find the sum of these quantities. So if I were to substitute, so therefore Sn minus 1 is going to be equal to, now clearly A is 1, the first term, okay, A is equal to 1 multiplied with, I have taken R to be as e raised to the power I of 2 pi divided by n. In fact, I'm not taking it, this is what we have obtained. So substitute that. So this is going to be e raised to the power I times 2 pi divided by n. This has to be raised to the power n negative 1 divided by or e raised to the power I times 2 pi over n negative 1. Now this is going to be giving me e raised to the power n, and n can be cancelled, giving me 2 pi, of course there is I there, negative 1 divided by e raised to the power I times 2 pi over n negative 1. Now we know that e raised to the power I times 2 pi is equal to 1. Now how do we know that? Now you need to know this formula. We already know e power I theta is nothing but cos theta positive I times sine theta. So e raised to the power I of 2 pi is going to be equal to cos of 2 pi positive I times sine of 2 pi. This is going to be 0 and this will give us 1. So using this, if I were to substitute it there, that's going to give me 1 negative 1 divided by e raised to the power I times 2 pi over n negative 1. So this is going to be equal to 0. So there is a very important result. So what is the result that we have obtained? Therefore, the sum of nth roots of unity is equal to 0. So this is a very important result. Okay, you need to know this.